Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 1, Lesson 4, Applications of the Normal Distribution.
Today we're going to look at applications of the normal distribution curve. We'll look at different word problems and we'll see how the mean and the standard deviation could be used to find out pertinent information to these particular problems. All right, so example 1. The heights of dogs at a city animal shelter are distributed normally with a mean of 25.4 inches and a standard deviation of 4.8 inches. We're being asked to sketch the normal curve and divide the area under the curve into sections that are 1, 2, and 3 standard deviations from the mean. And we're also asked, of the 73 dogs in the shelter, what percent of the dogs would you expect to be less than 20.6 inches tall? So if we first analyze this problem a little bit, going back to the word problem, it says the heights of dogs at the city animal shelter are distributed normally. That's a key thing that we need to note for this particular problem. Since they're distributed normally, then we automatically should know that the mean is going to fall within the middle of our curve. Okay, so that's key for knowing to place the mean in the middle of our curve, which is once again something that we learned last week. So the mean is 25.4, and that's in inches. So 25.4 inches. And we're also given that the standard deviation is 4.8 inches. So because the standard deviation is 4.8 inches, that means that we will add 4.8 so that we can get our next number, and in this case it's 30.2. Add another 4.8, and our next interval is 35. Add another 4.8, and our last interval will be 39.8. If we're looking to get the numbers on the left-hand side, once again, we go ahead and subtract 4.8, and we'll have 20.6. Subtract 4.8, and we'll have 15.8. And subtract 4.8 once more, and we'll have 11. All right, so we've so far used the mean. We've placed it in the middle of our curve. And again, the key part of this word problem that tells us that the mean should go in the middle is the fact that our data is normally distributed normally. So mean goes in the middle. And we also used our standard deviation of 4.8 to come up with the other numbers, the other intervals within our normal distribution curve. So essentially, we've taken care of letter A, sketched the normal curve and divide the area under the curve into sections that are 1, 2, and 3 standard deviations from the mean. And just to recap, 1 standard deviation from the mean would be here. That's 1 standard deviation, so ST. 2 standard deviations from the mean. This would be 2 standard deviations. And 3 standard deviations from the mean would be here. So just again as a very quick recap of what we learned last week. So those are your 3 standard deviations. 1 standard deviation is 1 to the left and 1 to the right. 2 standard deviations, 2 to the left of the mean and 2 to the right of the mean. So that whole section would be 2 standard deviations. And then 3 standard deviations, 1, 2, 3 intervals to the left and 1, 2, 3 intervals to the right. Together, that makes up 3 standard deviations. Once again, just a review. All right, so just because we've learned this last week and it applies to each of our standard deviation curves that we see or use, we're going to go ahead and write in the percentages for each of our intervals. So in the middle, remember that this interval is 34% of your data. Another 34% of our data. Then we have 13.5% of our data. 13.5% of our data. This here, we have 2.35% of our data. 2.35% of our data is here. And lastly, we have 0.15% of our data, and 0.15% of our data is here. Okay. And again, it's just a good habit to just go ahead and write in those percentages along with your mean and dividing everything into the 1, 2, and 3 standard deviations from the mean. So good to have all of it all at once, just in case you need it for any of your questions. All right, so moving on to part B. Of the 73 dogs in the shelter, it's asking us what percent of dogs would you expect to be less than 20.6 inches tall? So what percent is our question that they're asking us? What percent? So because they're asking us what percent of the dogs would you expect to be less than 20.6, first off, our answer should be a percentage. So whatever our answer is, it should be a percentage. So blank percent is going to be our answer. Blank percent is what we would expect to be less than 20.6. Okay. The next thing we're going to do is look at our normal distribution curve. And we're going to locate this 20.6 inches. And 20.6 inches is located here. What percent of dogs would you expect to be less than this 20.6? Well, less than 20.6, if this is a number line, numbers less than 20.6 would be all the ones that are located on the left of the 20.6. So that's all of this space, all of this region. Okay. So if we were to add up each of these percentages, our 13.5% plus the 2.35% plus the 0.15%, we're going to end up with 16. And that's in percent. So 16%. So just your side work, 13.5% plus 2.35% plus 0.15% adds up to give us 16.00%. So 16% would be our answer. So what percentage of dogs would you expect to be less than 20.6? Our answer is 16%. 16% of the dogs within this shelter have a height that is less than 20.6 inches tall. Example number 2. The heights of adult American males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5 inches. The questions we must answer are: A, what percent of adult American males are taller than 6 feet? And B, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? So the very first thing that we need to do in our directions, it didn't tell us to create our normal distribution curve this time. However, this is something that we need to know to do at this point. So if we're given that something is normally distributed, then go ahead and plot the information that they've given you on your normal distribution curve. So we're given that our mean here is 69.5. So 69.5 will go in the middle of our curve. Next, we're given that the standard deviation is 2.5. So we'll use that 2.5 to come up with the rest of our numbers. And they are 72, 74.5, 77 on the right. And then on the left, we have 67, 64.5, and 62. And as I recently mentioned, it is a very good habit to go ahead and write in your percentages for each of your intervals. So we have 34%, 34%, 13.5%, 2.35%, and 0.15%. and it's mirrored on the other side because a normal distribution curve is symmetrical. So 13.5%, we have our 2.35% and 0.15%. All right, so looking at our very first question, what percent of adult American males are taller than 6 feet? Are taller than 6 feet? Well, first off, if you're looking at your curve, we have 62, 64.5, 67, 69.5, 72, 74.5, and 77. I don't see a 6 feet here at all. These numbers are way bigger than 6. You must remember that each of these labelings are in inches. And because they're in inches and we're given a problem whereas we're referring to feet, we're going to need to convert those feet into inches so that we know exactly where 6 feet would lie in terms of inches. So let's think back. 6 feet and inches. Well, 12 inches equals 1 foot. In this case, we have 6 feet. Well, how many inches is that? That's 72 inches. So 72 inches are equal to 6 feet. How do we get it? Well, we would do 12 times 6, and it's equal to 72. So that's 72 inches. Okay, so then going back to our question, what percent of adult American males are taller than 6 feet? I'm going to erase this extra and simply put here that 6 feet is equal to 72 inches. So what percent of adult American males are taller than 72 inches? So let's locate 72 inches on our curve. We have 72 inches. Our key word here is taller. So taller than 6 feet or taller than 72 inches. Then those are the numbers that are located to the right of 72 inches. So we're referring to all of the space here. So then we would take our 13.5 inches, add it to our 13.5%, add it to our 2.35%, and add it to our 0.15%. And notice that our question is what percent? So our answer will be blank percent. So if we add those up, we have 13.5 plus 2.35 plus 0.15. That gives us 16%. So our answer is 16%. 16% of adult American males are taller than 6 feet, according to this data. Part B says, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? About how many? So first, noting our question, it's asking us how many of these adult American males would you expect to be taller than 6 feet? So our answer is going to be blank males. So we're looking to provide some number of males to answer this question. So blank males. So as we're thinking about the things that we've learned so far we've been looking for percents. What percent of American males are taller than 6 feet for part A? This time we're looking to say, well, if this was a group of 2,000 American males, adult American males, then about how many of them would we expect to be taller than 6 feet? For part B, we can use the information that we found in part A to our advantage. So very first thing, looking at it says taller than 6 feet. Well, we knew that each of our numbers here are all written in inches. So one thing to note is that 6 feet is really just 72 inches. So we're looking again at our 72 inches, which is still highlighted over here. Another key word is taller. So we're looking at about how many males are expected to be taller than 6 feet out of the 2,000. So remember our last problem, we were also looking at taller than that 6 feet or taller than the 72 inches. So we're still looking at this interval of space. So we found out that 16% of our adult American males are taller than 6 feet, which is the same as our 72 inches. So 16%. 16%. So to figure out then the answer to our question, if we have a group of 2,000 adult American males, but we know that 16% of them are taller than 6 feet, then we're really looking to answer the following question. What is 16% of 2,000? So what is 16% of 2,000? Because we found out that 16% are taller than 6 feet, and we have a group of 2,000. So then we need to know, well then, what is 16% of that 2,000? To figure out our answer, we would take our 16% and we would change it into a decimal, which is 0.16. We're going to multiply it by 2,000. So 0.16 times 2,000. 0.16 times 2,000 will give us 320. So in this case, the answer to our question is 320. I need to give some more descriptions. Adult American males. This is our answer, 320. So the difference between this problem and the problem before it, we were looking for what percent. So our answer should have been a percentage. This one now is asking us how many we would expect. So we need to use that percentage and then figure out, well, what percent of this total that we were given is, in this case, taller than the 6 feet. All right, next problem. The scores on the Algebra 2 final are approximately normally distributed with a mean, or an x-bar, of 150 and a standard deviation of 15. Let's first go ahead and fill in our normal distribution curve. All right, part A. If 250 students took the final exam, approximately how many students who took the test scored above 180? So if 250 students took the exam, that's important to note. That's the total amount of people who took the exam. Approximately how many students who took the exam scored above 180? So approximately how many students? Well, that's the part of our question. We're going to have blank students as our answer. And then it says who took the test scored above 180. So the very first thing that we need to do is find out what percent scored above 180. So what percent scored above 180? Well, here's our 180 on our normal distribution curve. Above 180 would be everyone in these two sections. So that's our 2.35% as well as our 0.15%. If we add those two up together, we'd have 2.35% plus your 0.15%. That gives us a total of 2.5%. So 2.5% of our students scored above a 180. But we have to go further. They want to know, how many students is this? So we need to figure it out then. What is 2.5% of 250? So what is 2.5% of 250? In order to do it, we need to change 2.5% into a decimal. This, we'd move the decimal 2 places to the left. So it becomes 0.025 and then multiply it by 250. And if you're using your calculators, 0.025 times 250 gives us 6.25. So 6.25. So our answer would be 6.25 students. But if you're thinking like I am right now, 6.25 students, how do you have a partial student? You can't have a partial student. So in this case, it would just be about 6 students would be our answer. Drop off the decimal. We can't have a partial student, and we're not going to round it up because we don't have quite 7 students. So this one, we'd round it to 6 students. About 6 students scored above a 180 on this test. All right, the next question, if 250 students took the final exam, approximately how many students scored above 135? So once again, we're going to highlight 135 on our normal distribution curve. And the percentage who scored above 135 would be everyone in this particular region. Okay, so first off, figuring out that total percentage of students who scored above 135. So the percentage above 135 is equal to your 34% plus your 34% plus your 13.5% plus your 2.35% plus 0.15%. And that gives us a total of 84%. Okay, so that was step 1. Figure out the percentage. Step 1. Step 2, and I'll say step 1. Step 2 is use that percentage and figure out what is 84% of 250. So what is 84% of 250? And 84%, we'll change it to a decimal. So that's 0.84. Multiply it by 250. And it gives us 210. So our answer becomes 210 students scored above 135.